Okay, so hello everyone. So welcome to the fourth live session for the course Geomorphic Processes, Landforms and Landscape, which is taken by Professor Javedin Malik from the Department of Earth Sciences, IIT Kanpur, and myself, Ananya P. Mukherjee. I'm a PMRF fellow, a PhD research scholar over here in Department of Earth Sciences, IIT Kanpur itself. So, as most of you all know, these sessions are to give you a summary of the weekly content and also help you in solving your assignment problems that are given to you every week. So, we are dealing with geomorphic processes, geomorphology. So, this course is all about understanding how landforms and landscapes are formed on Earth's surfaces and the processes that are involved in, shaping these landforms. So till now, we have seen an introduction to Earth as a system, the different kind of processes that are happening within the Earth, which are the driving forces driving forces behind creation of few of the landforms that we saw in, I think, in the week two live session. In the last live session, we started with fluvial geomorphology. Fluvial geomorphology is the changes that are brought about on the earth surfaces due to the action of river systems, the water that is flowing through a river system, what kind of work they do, which in turn results into the different geomorphological features that we see on earth. Okay. So, today's lecture is a continuation of that fluvial geomorphology itself. In the last class, we spoke about river dynamics. We spoke about how the river, from the start or the origin of it till the mouth of the river, what kind of, changes that are seen in the profile of the river, also in the landforms that we see starting from the origin to the mouth of the river. Okay. So these are some of the things that we have covered in the last session, and hopefully the content that was given to you and also the lecture recording which is put up in the YouTube channel that is maintained by me, that has helped you in solving your assignments. I will again put down the links for the resources and the YouTube channel where you will get the recorded lectures as well as the Google as well as the slides that I present over during these sessions. Obviously, these will be uploaded later on, maybe by tonight or tomorrow. And also, this is also updated in the sheet that is provided by NPTEL. But thank you for joining today, and hopefully, you will interact in the session as you all have been doing in the past sessions. Okay, so we will now begin with today's session. So we have learned that fluvial is the term fluvial is related to being of or originating from rivers. So because of the action of the rivers or because of the water flow that we see in the rivers, a lot of changes uh, are done because of the erosional and depositional work that is done by the river. Okay, so they differ at different stages of the river system. So if you remember, we had talked about different stages, youth stage, mature stage, and the old stage of the river. Okay, so uh, during the life river cycle or the life history of rivers, these stages are commonly seen, and the different landforms that are created during these stages of the river are very much. Yes, Manish, do you have a question?
Ma'am, what is the difference between mature and old stage of the fluvial landform?
Okay, I will get to that. So mature is where your depositional features as well as erosional features are happening, in kind of a balance with each other. Okay, so you will find erosional landforms as well as depositional landforms. Whereas when it's in a young stage, most of the work that is done by a river is erosional in nature. Okay, Why? Because first of all, if we know that usually rivers originate at higher elevated regions. Okay, so because of the gravitational acceleration, or the more potential that it has, it will flow with a much more it will the speed or the velocity is a bit more. Also because of the the rate of erosion and the rate of upliftment that is seen over there, they are also kind of balancing out, and that is why you see more erosional over there. In mature, you have erosional as well as you have depositional features over there. And then in old, mostly the at the old stage, the amount of fine particles or amount of sediments that are carried in the river stream is mostly suspended in nature. Okay, so that kind of reduces its erosional capacity. So mostly you will find depositional landforms that is associated with the old stage of the river. So this is the difference. Is that clear, Manish?
Yes, ma'am, very much. Thank you, ma'am.
Okay, no problem. Okay, so as I just explained, so we have three stages. You have young stage, you have the mature stage, and you have the old stage. So most of the landforms that are associated with the youth stage or the young at the young stage of the river, you will find valleys mostly. Okay, valleys, gorges, so these are areas which are, mostly elevated lands, okay, and the river is just, flowing through these elevated lands, and they're cutting through the rocks that are present over there. So mostly valleys are formed during the young stage. You will hardly find any depositional landforms. Depositional landforms meaning any particle, any of the material that is transported by the river, it does not deposit at the young stage. Okay, everything is eroded and then carried forward with the river at the young stage. Okay, so you find waterfalls. We had I had taught about the creation of waterfalls and rapids in the last live session. So these are all associated with the young stage of the river. When you come to the mature system, okay, mature system is where uh, you will find that there are more channels which are joining the river during the mature stage. Okay, more tributaries are being formed. Maybe the drainage system that is being, that is part of that river, it is also expanding. While it is expanding, it is eroding, as well as it is creating depositional landforms like floodplains, levees. Okay, these are depositional. You can see over here that you will find meanders and cutoff channels. Okay, broad, asymmetrical, symmetrical valleys. These are all erosional features. Okay, and then you will find there are also floodplains created. Then you have terraces that are created. Okay, point bars. These are depositional features. So at mature stage of the river, you will find both the erosional and the depositional landforms. While in the old stage, as I just explained, that there are very few tributaries. Okay, the rivers, the channels cannot erode as much as they were eroding before. Okay, another factor that kind of determines whether the river is going to erode or deposit is also the relief of the area. What is the relief? The elevation. Okay, mostly old stage of the river is seen in the flatter, regions of the continents. Okay, so like how deltas are formed at the old stage. Usually, where deltas are formed, there is not much relief. Okay, it is very close to the mean sea level of that area. Okay, so this is the kind of gradation that you can see, or the variations that you can see in the different landforms that are created by the river at different stages. Okay, so this is a kind of how the evolution of fluvial landforms happen with respect to the stages of the river, or the rivers, or the life cycle or the life history of the rivers. Now we come to another concept that is called the normal scale of erosion. Okay, so the erosion that happens with respect to the river channels, okay, so it is a kind of a cycle. Okay, and because Why is this called the normal cycle of erosion? Is because the most of the changes that we see in the landscapes and landforms, okay, with respect to the global scenario, most of the fluvial erosion is the widespread phenomena across the globe. Okay, so most of the changes that we see in the landscapes and landforms, rivers are very, very much commonly acting as the agents which are causing these landform changes. Okay, that is why it is also the most important geomorphic agent for us to understand. So then, where does the erosion begin? The erosion begins, okay, suppose in the first lecture, this is your glacial area probably, okay. So the glaciers are, accumulated at a point, okay, then they start melting due to seasonal temperature variations, okay. But if we don't have a gradient, okay, uh, if we don't have a gradient in the relief, okay, or there is no slope change, the water is not going to flow. Okay, so this is normal physics. If you apply anything that is at a inertia state, it is not going to move unless and until there is a change somewhere or the other. Okay, so a change of slope will kind of give the it will facilitate the flow of the water from from a glacial where it's originating to where it's going to flow and erode and cut through the different rocks and features that are already present. So that is the first step. When will there be a change in relief is when the area has had any upliftment or any tectonic processes has has increased the relief of the area with respect to the sea level. As the land rises, the water will start flowing from at a higher from the higher elevated regions to the lower elevated regions. This is what starts the cycle of the river, as we say, the life cycle of the river. Okay, so in the beginning, the rate of uplift is more than the rate of erosion, and then the relief kind of it follows. The relief for the flow of the river, it will start decreasing, so that like from the mountains it is going to come to the foothills and then to the plains, and then it will move to the to where it will meet the sea. Okay, during this time the erosion is happening, then the river valleys will be forming because of the erosion again. Okay, and then through the stages, as I explained before, through the stages the erosion will start decreasing, decreasing, and ultimately you will have very kind of a lateral uh, a lateral orientation of the features that we see, the low elevation area, more of the plain lands like floodplains and deltas. These are the things. So this is the normal cycle of erosion that is followed by a river system. Now, one of the features that are, formed due to this erosion is the river terraces. I'm sorry, there's a bit of a lag in the presentation today. Yeah. So what are river terraces? They are like, step-like features that are seen at the sides of a river valley. Okay. So one step is going to represent a level, a, a formal level, okay, a past level of the river valley. Okay. So it will shift with respect to the stream that is flowing. Okay. It might happen that due to uplift the areas, the river valley, the area next to the river or on the sides of the river will be uplifted. Okay, so the river will downcut more. Okay, so then one another step will be created for a while. It is going to flow in the new level. Okay, then with time again it will suppose there is an upliftment. Okay, so again the area will rise and the river will again downcut. Over here you can see, okay, with respect to time, how terraces are formed. So the T1 is the oldest surface. Okay, so originally this was the level over here. Okay, and the river was flowing over here like this. Okay, but later on, due to, as I said, the upliftment or any other tectonic change, if it has happened, okay, or maybe the amount of water that is flowing through that channel has reduced. Okay, any hydrological or climatic shift is going to facilitate this change or the development of the new terraces. Okay, then at time 2 you're going to see another terrace. Okay, so over here you can the rate of incision. Okay, the incision of the, like, how fast or how slowly the river is cutting through a region is given by the rate of incision. You can calculate it by the height of the terraces and the age of the terrace surface. Okay, so if suppose the height of the terrace is uh, higher, or it's a larger height, okay, that means the incision or the the rate at which the river has cut through that area is very fast. Okay, it has done, and the change between the levels of the level of the valley has not changed, has changed very fast. Okay, has not changed, has changed very fast. Okay, so this is how you can understand that how fast the rate of incision is of a river. Okay, and there could be two types of terraces that we see, that is erosional and depositional. Erosional terraces are usually seen in areas where you have very solid bedrock present. Okay, what is bedrock? As in these are rocks, okay, on which you will find a lot of sediments being deposited. So where erosional terraces are formed, mostly sediments are low in quantity with respect to the bedrock that is present. Okay, over here you can see that the second one is the erosional. Okay, this is your erosional terrace. This strath, these are also called strath. Okay, you can see there are some depositions, these yellow mounds, but the quantity is less. Okay, mostly you will see that erosional terraces are formed in the elevated areas, or mostly near the at the young stages of the river. Then what another terrace that you have, that is the depositional terraces. Okay, suppose the river is flowing through thick, where thick alluvium layers are present. Okay, so over there also it will start down cutting as and when there is a shift in the the river, the flow, the level at where the river is flowing. So it will cut through those sediments. Okay, so that is called depositional terrace. Mostly where alluvium is more in quantity. Okay, and the erosional is where you have the bedrock, the in more in proportion. Okay, so as river terraces can give you an idea about what is the present floodplain level and what was historically present. It will also give you an idea about how tectonically active that region was, or what the if there was more flooding in those areas, or there was less flooding. So these are something that you can understand by studying river terraces, and the it will give you the rate of incision as I explained before, and that will help you in understanding the river dynamics of that region also. So another
Ma'am,
aspect that we see during the erosional erosional work of the river is river rejuvenation. Okay, what is river rejuvenation? Conceptually, if you understand, suppose the river is flowing at a level which is similar to the sea level. Okay, so it's flowing. There is no new formation, or there is no new stream formation, or there is not much, land being exposed to, for a newer landform to, form. So a river will be said to be rejuvenating when the base level is lowered compared to the sea level. Okay, so you can have two kinds of changes, that is isostatic change and eustatic change. What is an isostatic change? That is when the land is moving up or down with respect to the sea level. Okay, so the changes are maybe tectonic in nature. Okay, so those are isostatic change. What the sea level remains as, like, whatever it is at the present level. Okay, the sea level is not changing, but the land has changed with respect to the sea level. And eustatic is when there is a rise or fall in the sea level. Okay, so obviously if more ice is going to melt, your sea level will rise. And if there is there is not much melting of ice, okay, so the sea level with seasonal variations, the sea level will decrease. Okay, so these two changes could cause river rejuvenation. Okay, so how does river rejuvenation? The first is like the normal, okay, where the river is entering into the sea, it is maintaining the sea level. Okay, suppose over here you see that there is an uplift of the land area. Okay, so since the sea level has gone down now, like the land, or you can say the land has, moved upwards with respect to the sea level, you will see it has got a bit more land surface now, or you can say the relief has changed now. Okay, now to flow to the sea, it has to cut through that area. Okay, so the floodplain has already developed. Now the river, because the relief has changed, will, cut through the floodplain that has already been created. Okay, now it will create a new floodplain with respect to the sea level that is now present. Okay, and the area where you will see the relief has changed, it might form a waterfall at that area. Okay, and then suppose the sea level is now, over here, as you can see it, this is where the relief has changed. Okay, now slowly, because of the erosive work of this segment, this widens. Okay, the region over there, okay, it will start widening, and it will shift the waterfall back. Okay, so this entire process is your river rejuvenation process. Okay, now if we suppose we take longitudinal kind of a section along the the path that is the river is following during the rejuvenation, you will see that these points, okay, where the relief has changed or where the sea level has changed, okay, these are called nick points. Okay, there's a sharp change in the gradient of the slope. These are the nick points. Okay, so over here you can see that at first this was your at T0, your sea level was over here. Okay, then suppose there is a fall in the sea level. Over here we are considering fall of the sea level. In this diagram we had considered the uplift of the area. Okay, to understand river rejuvenation. Over here, so at T0 this was your original sea level. Then at T1 sea level fell because probably, as mentioned before, maybe ice cap was not melting enough. Okay, so there is no more, the amount of input to the sea has reduced. Okay, so the sea level has fallen down. You will find another nick point over here because this is the first nick point, okay, where the change has happened from T0 to T1. Then again there is a fall in the sea level, and this is the present sea level. Okay, so then again you will see that this is another nick point that has been formed, and due to the change over here you will see that again there is a new floodplain being formed over here, and then this becomes your mouth region of the present at the present sea level. Okay, so river rejuvenation is another kind of a process where more area or more land is getting transformed into floodplains or other features that are created by the river systems that are flowing. So river rejuvenation is kind of the erosional work that is done with as a response to the changes in the land, the land level or the sea level, with land changes or the uplift due to the with respect to the sea level of that at the present time. Okay. Over here, you can see that there are three different kinds of rejuvenation, or three types that rejuvenation that can happen. That is dynamic, that is your result of isostatic change, where I said that the land rises, okay, maybe due to faulting or any other tectonic or geological, process, okay, and the river has to erode downwards, okay, downstream, or there is a, more erosion towards the sea. Eustatic rejuvenation is due to the global sea level change, as I mentioned before, because of ice caps melting or getting accumulated over time and not melting faster than the accumulation rate. Okay, so when the sea levels will fall, the mouth of the river, it goes more, it will affect the mouth of the river. Okay, so where the mouth of the river should be, close to the land area, it will move slowly towards the sea area. Okay, maybe as I mentioned, as over here you can see that at first the mouth of the river was present over here. Okay, then due to the eustatic changes, the mouth of the river shifts towards the sea. Okay, then you have the static rejuvenation, that is due to the changes in the load that is carried by the stream. Okay, or suppose there is an increase in the runoff, that is a water that is being carried by the river. Okay, due to the glacial melting. Okay, due to the increase in runoff, it could lead to deeper valleys being created. Okay, but to account or to hold the entire the increased runoff, the river will downcut more, okay, to accommodate all of the water that is flowing. So it will result into increasing the depth of the valleys that are created. So why is it important to understand river rejuvenation, or why does it happen? Is that the river throughout its course, it will maintain a concave profile that we see over here. Okay, it will start with a steep gradient, or the at like where the rate of sloping of the area is more, and then it moves to the gently sloping areas or having gentle gradient. Okay, so if it is disturbed, or if the normal behavior of the current river system is disturbed, the adjustments that the river will make will be so that it can come back to this same long profile. It will again come back at a state, okay, where this is maintained. So it will always maintain this steep gradient and then going to gentle gradient, no matter what kind of changes or what kind of disturbances the river system is going to face. Okay, now we come to channel patterns. We briefly discussed this even in the previous live session. Okay, channel patterns are, resulted, they result because of the erosional and the depositional work that is happening together when the rivers are flowing through an area. Okay, due to the maybe a disbalance in the rate of erosion and the rate of deposition, or the sediment supply that the stream is carrying, or the kind of maybe there is a tectonic disturbance in that area. Okay, so the channel patterns that are formed will be a response of the changes in these factors. The figure over here, this is the Schum's classification, okay, of the channel patterns. Okay, so if you have a suspended load, more of suspended load, okay, and it is flowing through a low gradient area, that is a flatter area, okay, and the width and the depth ratio is low, as in the width and the depth are almost similar, okay, in terms of each other, and it is a very the channel flow or the river channel is at a stable, there is not much instability in the erosive work and the depositional work. Okay, so this will be a straight channel. Okay, as and when the gradient increases, maybe, okay, or there is a change in the width and the depth ratio or in the stability of the channel, okay, you will see that it turns into a meandering stream. When this is for a suspended load, okay, suspended load means that it has smaller sediment size and the sediment load is also not that much, okay, and the flow velocity is also low, and also the stream power is low, and the total bed load to the total like there is less of bed load. What is bed load? Bed load are the bigger sediments that are found, okay, that is called bed load. If there is lower bed load and more of suspended load, usually these streams are going to flow in a straighter channel, and then with changes in this gradient, okay, you will see that it will start meandering. When you have mixed load, okay, mixed load as in the bed load and the suspended load are kind of equal in proportion, that is being transported by the channel. Okay, so the flow, the channel might appear, it will appear a straight channel, okay, but these depositions that are there, okay, these will kind of give it a sinuous or a curvy nature. Okay, so in this diagram, you can see that with respect to the changes in the, the gradient of the area or the width and the depth of the channel, sediment size of the load that is being carried, the flow velocity and the, amount of sediment load, the proportion of both the loads, you can classify these into these different channel patterns. Okay, this is a straight, this is a meandering one or sinuous channel, this is also a sinus channel. This is also a meandering channel. This later on, when the it starts broadening a bit more. The channel starts broadening, but there are a lot of depositions also in the middle of the channel. It will become more braided in nature. Okay, so these are mostly braided channels. These are meandering channels and these are straight channels. Okay. So this is Schum's classification, and then over here you can see that these are channel changes that are expected along alluvial rivers. Okay, alluvial rivers as in they are flowing through alluvium rich areas. Okay, so the bars might shift or there is alternate placement of the bars with respect to the river channel. This neck cutoff causes the formation of an oxbow lake. Then you have shoot cutoff, then you have meander shift. Okay, you can see that the sinuosity or the sinuous nature kind of decreases when the meander is shifting. Okay, then avulsion is that it is it was flowing through one area, it eroded, it got a lot of the material that was present starts eroding, and there is an avulsion or the change in the direction. Okay, so these channel patterns are developed because of a kind of a relation between the erosional work and the depositional work that is done by the river. Okay, now we come to drainage basin or watershed. What is a drainage basin or a watershed? It is the kind of it is the entire area that is being supplied by water and sediments by one river system alone. Okay, and suppose there are two river systems which are forming drainage basins. Okay, so there is an area which is going to demarcate the boundary between say drainage basin A to drainage basin B. That is your drainage divide. Okay, we had learned some part of this even in the previous live session. Okay, so you can see that this entire area is a watershed. Okay, this is your drainage divide, this is your main river channel. Okay, so this is the source, and then there are different kind of tributaries that are joining, and it is forming the main river channel over here. Okay, So these are the tributaries, and wherever it is joining the main channel, okay, these are confluences. One of the important confluences you all might have heard about is the Dev Prayag, where Bhagirathi River and Alaknanda River, they come and they form Ganga. Okay, so that is the confluence. That is the confluence of Ganga, and then Ganga starts flowing as one main river channel over there, from there. Okay, so that entire area, okay, from where Bhagirathi and Alaknanda rivers are meeting, and then they are forming Ganga, and that area from there is all the drainage basin of Ganga, Ganga Basin as we call it. Okay, so over here these are some of the terminologies that are related to the drainage basin. Drainage basin is the area. I'm sorry, this okay. Drainage basin is the area or the land that is drained by one river system. Okay, catchment areas is the area within the basin. Okay, catchment area is where the water is kind of flowing through those areas. Okay, watershed or drainage divide is the edge where it is demarcating the boundary between two different drainage basins. Then you have source, you have confluence, a point where two rivers or streams join, tributary, stream or smaller stream which joins a larger stream. Okay. I'm sorry, I think there's a repetition of the. Yes, Manish, do you have a question?
Yes, ma'am.
Yeah.
Ma'am, my question is, what is the difference between catchment area and watershed?
Okay. Watershed is it relates to the area that is acting as the boundary of one drainage basin. Okay. Catchment area is the area that is inside that watershed.
Okay, ma'am. Okay, thank you.
Yeah, when you say watershed management, it is only, we are talking about the area that is making up the boundary of the drainage basin. Catchment areas and the entire area that is within that boundary. Okay. There is a
Okay.
repetition of the content over here, so I'll delete this part when I'm uploading the slides over here. So now we know what is a drainage basin, and we know, how it is, holding, or it is kind of, being supplied water by one river system. And this drainage basin, with time and with again erosional work and the transport work and the depositional work that is done by the river, it will evolve with time. Okay. Again, this is related to the three different stages of the life cycle of the river that we spoke before: the youth, the mature stage, and then the old stage. Okay, so the old stage, it will actually just form a delta. Okay, that is where the drainage basin kind of it ends over there. Okay, so the drainage basin evolution. Okay, evolution will only happen if there are changes. Okay, and these changes are mostly, they occur before the old stage. Okay, so over here you can see in the youth there are more straighter channels. Okay, you can see there are more straighter channels, and most of the area is covered by the main channel. Okay, and there are smaller streams, and with this length of the streams are also less in the youth stage. Okay, and most of them are straighter channels. Then after a while, okay, the channels are going to get bifurcated into more smaller channels, the main channels or the tributaries. The nature of the flow or the nature of the channel pattern also changes a little. From straighter, it will start, getting more sinuous in nature. It will start migrating from its previous place to the other place because of the erosional work. Okay, and you can see that the number of smaller length of streams is increasing. Then at a mature stage, you will see that the spaces between the main channel and the tributaries increasing because of the development of floodplains due to more, depositional work that is being done. Okay. Then you have the maximum extension. Maybe there is, kind of a boundary, say maybe uplifted or elevated area, okay, beyond which the river cannot extend anymore. Okay, so that is your maximum extension. It has reached towards your watershed or the drainage divide. Okay, now when it has reached its maximum extension, it might not go beyond, beyond the certain area, but within the catchment area, you will find some evolution. Okay, that is, maybe it will, maybe two smaller channels will, somewhere they will join and they will form a bigger channel. Okay, some channels will get cut off, maybe because the supply cannot reach, or the discharge in that channel is much lower than it is required to maintain that channel, so that channel might get defunct. Okay, you will have river capture is one, river capture, river piracy is a term that we that is associated with fluvial landforms. Okay, so these are the different steps that is involved in the drainage evolution. Okay, so the channel patterns kind of change, the sediment load changes, the drainage evolution could happen due to changes in relief. Okay, tectonic upliftment that we see. Okay, and then maybe even the drainage pattern or the drainage system that the river is following. Okay, it might also change with changes in the lithology that is kind of that the river is meeting when it is flowing through the drainage basin. Okay, so these are some of the factors that are going to help the drainage basin to evolve. To understand the evolution of the drainage basin, okay, uh, how it is, whether it is at the youth stage or it has, reached its maximum extension. Okay, so we study about something that is drainage morphometry. There's issue with the gene. Yeah, okay. So drainage morphometry, so you will, these are few of, quantitative, uh, analysis which explains you the drainage evolution or the stage at which the drainage basin is kind of evolving. Okay, in the we kind of went through this in the previous session also, but now I will explain you with kind of how numerically you can understand the bifurcation ratio and how it is different. Okay, suppose these are two drainage basins we are considering. So the what are the stream orders? Stream orders is, it is dependent on the branching pattern of the stream. Okay, so so the stream or the channels which are not making up or getting bifurcating in different channels. Okay, suppose there's only one channel. Okay, now this is not forming another channel from here, or there is no division where it is kind of splitting into two different channels. Okay, so the channels which are not splitting into more channels, that is your first order stream. Okay, lower number stream order is given to those. Now when two lower number or lower order streams are joining, they are forming a higher order stream. Okay, uh, Manish, do you have a question? Okay. Okay, so the two first order streams are going to join and make up the second order stream. Okay, so the second order streams then after a point they will join, two second order streams will join and form the third order stream. So this is how the order of the streams are given. Higher order streams, if they are present, that means it is more evolved drainage basin. Okay, this you will understand when I'm explaining. Okay, when you consider, drainage density is the ratio between total length of streams in the basin and the drainage basin area. If you have more orders of stream, okay, the stream orders are much higher. Suppose you have seven stream order or eight stream orders. Okay, so every order will have, every order stream, if you calculate their lengths, okay, so it will be higher if you have a higher order, if the drainage basin has more number of different orders of streams. Okay, So that and the area is suppose say constant in one particular area. If you consider a drainage, a drainage pattern that has less number of streams. Okay, suppose you consider this example here. Suppose this area and this area is same. Okay, for example, the the total length of streams over here is going to be much lesser than this. Okay, this is, you can see it from the eye. So that means that this is much denser than this. Okay, this drainage density is related to this bifurcation ratio. Okay, over here, if you see, if you consider the bifurcation ratio between first order stream and the second order stream, you will see that there are, 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 first order streams, okay, and you have 3 second order streams. Okay, so your uh, the ratio becomes 3 over here, bifurcation ratio between first order stream and second order stream. If in this example you count, you will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so you can calculate this on your own. Okay, and you will see that as and when the number of this will increase, okay, with relation to this, okay, you will find that the bifurcation ratio will be different. Okay, depending on that. And then if the bifurcation ratio is, kind of more, it will be a denser drainage system. Okay, so this is a quantitative analysis of how much the drainage basin has evolved with time. Now the another factor, okay, which is involved during the evolution of a drainage basin is called river piracy or river capture. Okay, so what happens during a river capture is, suppose there is a river that is flowing from one area. Okay, over here as you can see, this is a river system. Okay, this is suppose, one watershed. Okay, so you can see there is a watershed divide. Okay, this is one drainage system. Okay, and this river is coming, and the erosion, the headward erosion or downstream erosion is increasing with, suppose say, steeper slope present over here. Okay, soon what will happen due to the headward erosion of this river is that it will erode this area also. Okay, and since this is flowing in this direction, because of the erosion or because of this watershed divide, coming and meeting over here, this river will capture this river. Okay, river A will capture river B, and this will get cut off over here. The river B will no more flow in this river. Say, suppose this is your river C. Okay, and because of this river capture, now the river A has also taken up this part of the drainage basin or the, the catchment area which was first present for in this basin. Okay, so this is an example of river piracy, and you can see that there is a 90-degree bend. Okay, suddenly your drainage pattern has also changed over here. Okay, and because of the river piracy or the river capture, a basin area has been incorporated in the other river, or the river which was pirating or which was capturing the, the pirated river. Okay, river piracy happens kind of, when the drainage basin has, reached its maximum extension. Okay, I said before that maybe the shorter, the smaller stream orders, they are kind of, they are not getting probably say any more, the water flow is probably not as much to, supply water in those, and the drainage basin or the stream that is flowing in the neighboring drainage basin, maybe the erosion is much faster in that stream, so it will erode through the watershed divide, okay, the drainage divide, and it will capture the stream. So then it will take up some part of the drainage basin of the previous of the one where the which was flowing and it has reached the maximum extension. So river piracy is one of the additional processes that happen during the drainage basin evolution. Now we learned about drainage basins, we learned about how different kinds of channel patterns are formed due to the erosional and the depositional work. Now drainage patterns are dependent on few other things. One is the kind of the structural trends that are present over the region, okay, and the rate of disturbances that it is facing during its flow, and also the lithology that is present over in that area through which the river is flowing. Okay, so the drainage patterns which are kind of dependent on the structural trends or the the slope of that area or the stability of that area. So these are concordant drainage, discordant drainage, and superimposed drainage. Okay, so concordant is when the river that is flowing or the stream that is flowing, it will follow the trend of the underlying geological strata. Okay, so that is a concordant where it is conforming to the trends or it is flowing according to the trends that are present. What we see in discordant drainage is that it bears no relation to the current structure of the rock. Okay, uh, discordant drainage, antecedent stream, we spoke about this in the previous session. Antecedent streams are, part of discordant drainage. Antecedent streams, that the way it was flowing previously, okay, the suppose the river formed before the formation of the topography over there, okay, or the structural features that we see, even after the formation of the structural features, the flow of the river has not changed. Okay, over here you can see that the river was flowing like this only. Even with changes in uplift or faulting over here, the trend has not changed. Okay, from yes, Manish, do you have a
Hello,
question?
ma'am.
Yes,
Yes, ma'am. Ma'am, antecedent और एक बार फिर से बता दी मैम antecedent.
एंटीसीडेंट। हाँ, एक
Yes,
मिनट,
ma'am.
मैं वो डायग्राम दिखा देती हूँ पिछले क्लास में जो कराया था। Okay, I don't have a diagram, but I have an explanation over here. Okay, so the drainage pattern was already present before the uplift. Okay, so suppose if you consider the Himalayan rivers, okay, most of the Himalayan rivers are antecedent. That means they formed in that area before the Himalayas, formed over there. Okay, and they are flowing in the same way as as they were flowing before the formation of Himalaya. Okay, so they are not changing with respect to the tectonic changes that are happening over there. That is what is antecedent drainage. That is called a discordant drainage. Okay, antecedent is a form of discordant drainage. Did you understand?
Yes, ma'am.
Yeah, so the rate of uplift and the rate of erosion of the river, of the antecedent river, is almost similar. तो जैसे जैसे uplift हो रहा था वो उतना ही वो erode कर करके वहां से निकल रहा है, ठीक है? तो it will not change its kind of flow direction or its course because of the changes in the uplift or the of the region. Okay, yeah. So concordant से फिर it can go to discordant. Discordant में there is another drainage system that is called the superimposed drainage. Okay, that means that a part of the area has been eroded away. Okay, drainage basin is developed on a rock strata that have since been removed by erosion. It is again a type of discordant only. That means कि वहाँ पे erosion हो गया है, ठीक है, ऊपर वाला part like the upper surface has been eroded away, but the drainage system is still flowing in the similar manner. Okay, over here you can see that this has lowered. Okay, sorry, yeah, yeah. So over here, you can see the downward arrows, as in, the erosion has, kind of decreased this area. Okay, suppose this is being removed, but the river is still flowing in that same way. Okay, so some of the examples that you have is the Chambal River, okay, and Damodar River. Okay, so these are kind of, superimposed drainage examples of these superimposed drainage pattern. Okay. So over here you can see that deformation was there before the stream was present. Okay, then the down cutting also happened, and there the erosion is also happening in the same way, but the stream still is flowing through the in the similar way. Okay, that it was flowing before. For concordant streams, you have different kinds of streams. You have consequent stream, you have subsequent, subsequent, and resequent. You can see,
Ma'am,
huh?
then what is the role of erosion in the superimposed stream?
सी डिस्कॉर्डेंट ड्रेनेज बेसिन का ही एक पार्ट है, एक टाइप है सुपर इम्पोज, ठीक है.
हाँ.
एंटीसीडेंट इज वेयर देयर इज टेक्टोनिक अपलिफ्ट. Okay, in superimposed, the uplift is also happening, like change is also happening, and erosion is happening. But still, the
Okay.
drainage pattern is
Hmm.
same.
Okay.
Okay, so it is superimposed. Two
Okay.
kind of two tectonic uplift is also there, erosion is also there. Okay, two kinds of changes have happened in that area, but the drainage pattern is remaining same. Okay, so that is superimposed. And then again, when we come to the consequent or subsequent, these are concordant, as in they change with respect to uh, the trends that are seen over there. Okay, so our direct consequence of the Yes, sometimes it's easier to explain some things in Hindi, so it is easier to understand. I have no issues with Hindi. If anything, if you want me to, say something in Hindi, you can ask me. Okay. So for consequent streams, that is part of the concordant streams. Okay. So consequent is the direct, direct implication of the or the direct result of the initial topography or initial slope. Okay, so the consequent like this is due to this elevation. Okay, this relief change that we see. Subsequent is, you know, it kind of is forming from the consequent, or it is joining the master consequent stream. Obsequent streams is the direction is opposite to the consequent. See, the consequent one is flowing like this. Okay, the obsequent is will be flowing like this and joining the subsequent. Resequent is in the same direction as the initial consequent stream, but it is in the response of the the relief changes. Resequent. Okay, it will flow in the same direction, but it will be formed due to the changes in the relief that we are talking about. Okay, when we are talking about concordant drainage systems. Concordant drainage systems will flow with respect to the slope that is presently existing. If the slope changes, concordant drainage patterns will also change as a response. Okay, so these drainage patterns, these concordant, discordant, the antecedent, superimposed or consequent streams, these are all termed or classified with respect to the response of the flow direction of the rivers with respect to the changes in the slopes or changes in the kind of tectonic regime of that place. Now we come to drainage patterns which are affected or classified based on the kind of geological structures that we see and the lithology. Lithology means the rocks that are being that are found in that area. Okay, so you have dendritic, which is kind of irregular branching. Okay, it appears like a tree, how trees have branches, it is spreading across the entire area that it has. Okay, so dendritic is that tree shaped kind of a drainage pattern. Okay, it is haphazardly it is flowing. When you find dendritic system, that means that there is not much change in the lithology that is present over there. Okay, and the slope of the area is gentler in nature. Okay, and it kind of, forms over like large areas with similar lithology. Okay. Then you have parallel. These are usually formed in places where you have steep slopes. Okay, suppose as a child, we might have, created mounds, or when we suppose go to beach, we make a big mound and then we pour water on top. Okay, so the kind of the pattern that is formed over there is, similar to this parallel one. Okay, it will flow parallel to the streams will be parallel to each other. It would be okay. Like you want real life examples. Okay, I'll try to include those when I will, kind of upload the slides. Okay, I will try to include one real life example of each of the, at least the common drainage patterns that we see. Okay, thank you, Kuldeep, for bringing that to notice. Yes, I'll include those. So parallel channels that they are nearly running parallel to each other, they are forming in like steep slopes, okay, and in areas where you have parallel elongated landforms. Suppose, as an example, you can see that suppose there is a high flatland elevated area. Okay, suppose the river there is accumulation, and there is a steep slope. Like yeah, suppose the mountain tops are kind of flatter, and then you have steep slopes. Okay, suppose this area is like this. Okay, so if the water is kind of a different kind of streams are coming here, these streams, or suppose the water is flowing over here, overflowing and then coming down, you will find that over here it will form like these parallel slopes. Okay, and between the two streams over here, there will be like a ridge, elongated ridges that are forming. Okay, that is just like idealistic example of how it would look. Then you have trellis. Okay, so the trellis also, like the main stream is going to run, the main streams are parallel to each other, and the smaller streams that are, either flowing into the river or flowing from the main stream are kind of, at right angles to the main stream. Okay, so this is a trellis. Now, these are usually formed in dipping or folding sedimentary or metasedimentary rocks. How will it look like, suppose, there are folds here. Okay, these are folded mountains and the stream is flowing like this. And this is also elevated. Okay, there is a slope change from, this direction to this direction. Okay, so this is flowing like this, but because, these are also elevated and these are also sloping. Okay, so these will go like this, and these will also, form 90-degree angle. Okay, and these are very closely situated. The main channels or the streams are, kind of closely situated. So it will form like almost parallel. Then you have radial. Radial is very easy to understand, whether you have a dome at the center or a basin at the center. Okay. So it is mostly radial is when the streams are originating from the central point. Okay. So you have maybe, suppose uh, there's like a volcanic dome, okay, and later on it is water accumulated over there and it's flowing down from that volcanic dome. Igneous intrusions, okay, so these are usually these areas are where we see radial drainage pattern. Then you have annular. They are like ring like patterns. Okay, there's a difference between radial and annular. Okay, so the main streams are kind of forming into a pattern, a ring sort of pattern, and radial is that it is originating from a central elevated area, then it's flowing down. uh Chota Nagpur Plateau, for which one are you saying? The radial, Kuldeep? Radial one. No, it's mostly a dome. A plateau is where the surface is, kind of flat on top. So, I'll try to give an example. Right now, I'm not getting, proper geological example for this, but I'll give it to you. Okay. Then you have annular, that is your ring-like pattern, okay, or structural dome. Then you have rectangular. Okay, so rectangular patterns are usually found in areas where you have lots of joints. Okay, what are joints? Joints are, kind of fractures that are developed in a rock. Okay, so these are fractures that are present. There's no displacement along these fractures. Okay, but these are jointed. Joints, as in, like, they are connected to each other. They are linear fractures that are seen in some rocks. And faults are where a displacement has occurred along a fracture. Okay, so rectangular drainage pattern is seen in areas where there are a lot of fractures and joints present. Okay, so also sandstone and quartzite are two kinds of rocks where you find a lot of joints, and that is why rectangular drainage patterns also develop in areas which are made up of sandstone and quartzite rocks. Okay, these are some other drainage patterns. These drainage patterns, the ones that I introduced before, are most widespreadly, the found in widespread. Okay, it is globally. um, lot of the river systems are actually found in, in these drainage patterns. These are some, like, these are also found, but they are not studied in depth a lot. Okay, only few of the examples over here I'm going to talk about. If I find, proper geological examples of any of these also, I'll try to include them in the slides. Okay, so you have pinnate, and then you have angular, you have centripetal, subdendritic. Okay, so subdendritic is similar to, the dendritic, but it is more elongated in nature, and dendritic, you could see that it was branching out more on the, kind of lateral regions. Okay, so then angular is that they are, kind of, again, these are also found in jointed areas. Okay, suppose, the joints are not at right angle to each other, but they are at angles. Okay, so the river might flow through these joints and then form the angular drainage pattern. Okay, centripetal is similar to radial, but in radial, it is, the streams are flowing away from the central accumulation point. In centripetal, the streams are converging and, flowing in towards a central point. Okay, so a crater, a basin. Okay, so these are, examples of centripetal drainage basin. Okay, so pinnate is, where the density is a lot. Okay, so the drainage density is, higher over there, and it will, cause, like, how you see feather are, like, like this feathers, you see a lot of feathers, or the veins of, not a veins of the leaf will become dendritic pattern. Consider a feather. Okay, so all the hair is, connected to that one main ridge. Okay, so it will appear like that. So these usually form in areas which are, where there is a lot of fine size sediments are present. Okay, pinnate type of drainage patterns. I will try finding examples for these, and I will include in the slides. Okay, now we studied about fluvial landforms. Okay, how they are, forming different features on the Earth's surface, uh, in what way it is eroding, in what way it's depositing or forming depositional landforms. Okay, how it is helping shape the Earth. Okay, but some of the action, or, fluvial or the action of the river systems, or the water that is flowing through the rivers, is going to affect negatively on the life and property that is present right now. Okay, now some of these, some of the processes that are causing floods, okay, due to the changes in the water levels of the river system, some of them are natural in nature, and some of them are man-made. Okay, so the factors which are going to, affect the intensity of the floods, size and nature of the river, the vegetation that is present in and around the river, structures, levees, and downstream water levels. Okay, these are some of the natural factors that are going to affect the intensity with which the floods are being caused. Okay, in this, kind of sketch, you can see that there are a lot of inputs to the river system. Okay, and changes in the any changes in these input factors is going to determine whether a flood will be caused or not. Okay, so if your catchment vegetation decreases, okay, so the sediments are more loose in nature. Okay, so it will it will not hold the water, it will flow, and it will flood the region next to the river. Okay, it will erode the area next to the river. Okay, because of kind of failures in dams. Okay, that is kind of man-made. Okay, we dam is a man-made feature, but a sudden release of water in dam is going to increase the water flow, increase the water level in the stream, and it might cause flooding in the region that is nearer to the dams. Okay, suppose you have cloudburst or heavy rainfall, heavy precipitation, that again is going to change the water level in the river and cause floods. Okay, suppose your floodplain structures have you have removed those. Okay, the natural levees that are formed, you have removed those, so you're increasing the area which could be affected by the floods. Urbanization is obviously one of the man-made factors that is going to affect the occurrence of the floods. Okay, uh, then you have the surface runoff also. The more concretized area, like the more concrete areas that is present, okay, so the runoff is going to be higher. The water that is flowing on the surface is not getting absorbed, flowing on the concrete. Okay, if you put concrete in place of the natural soil that is present, there is no absorption, and the entire water that is falling in such concrete areas is going to flow into the river. Okay, it is going to increase the water level, and it might cause flooding in the area as well as in the downstream areas. Okay, so these are some of the factors that affect the nature of the flood that is going to cause, or the intensity. Okay, now this is a storm hydrograph, or you can also call it as a flood hydrograph. Okay, so this plot is kind of shows you the uh, kind of nature of the discharge, with respect to the time and the input of the precipitation or runoff. Okay, so the runoff or storm flow is the water that arrives in the river via surface runoff. Okay, or sudden through fall through the rock. Suppose the rainfall has happened some at some other place. Okay, and due to the surface runoff, it has come from that place to the river. Okay, so runoff, as we call it, the storm flow, is the water that arrives into the river due to the surface runoff. Okay, or through a flow. So the rising Okay, so the rising limb over here is giving an indication of how fast the water is reaching the channel. Okay, and it also shows how fast it is the water level is increasing in the channel, the rising in the channel. Okay, so this is, suppose, say your this is the amount of water that the river can carry. Okay, or the amount of water that is in the river at that point of time. Okay, and then as the input of water is increasing, okay, so first you have through flow. Okay, that through flow is what that can just go into the area that is next to it. Okay, it is not going to cause flooding. But if the discharge increases more and more with time, and it is the rise is also very rapid, this is where the storm runoff is being accumulating, or the storm runoff is being received by the river. Then there is a kind of threshold, okay, beyond which the river bank is not going to hold any more water, and flooding will be, flooding will take place. Okay, over here you can see bank full discharge is the level, okay, at which the flood could occur. Okay, this varies from river to river. Why it varies from river to river? Because again, the discharge that is there for a river will again depend on the density, the drainage density, the vegetation that is there, or the shape of the drainage basin, or the type of the drainage basin. Okay, so these are affecting the, bank full discharge level of every river. Okay, and this is the peak discharge. After peak discharge, there is going to be a fall in the water level. Okay, so peak discharge is, after the bankful discharge, flooding has happened. Okay, the discharge amount has reached its peak. Okay, after that, the water level is going to recede. Okay, after the, there is no more input of the runoff. Okay, there's no more input of the water into the channel. Okay, after that, with time, it will start receding. Okay, and this is called the recessional limb, falling limb. Okay, so you can understand, the steeper the rising limb, okay, so the more chances of the floods of occurring. Okay, if suppose this was like a gentle slope, okay, so maybe this is your bankful discharge. Okay, the rise in the water or the rise in the runoff is not very, it is happening slowly with respect to time. Okay, so this is a gentler slope, so the chances of flooding during, kind of this kind of a storm is low. Okay, but if your rising limb is, it is happening at a, at a steeper, the limb is, showing a steeper response, that means the chances of flooding is more in that. Okay, and as I said, the falling limb shows the river as the level is falling. So over here you see that even if the, rainfall event has happened a day before the flooding, okay, it depends on the amount of precipitation. Okay, the peak rainfall is supplying the runoff. Okay, it has happened a day before. Okay, but still there are chances of flooding. It depends on the amount of precipitation that drainage basin has received. Okay, now as I said before, then the flood density or the amount of discharge that is, flowing through the stream is dependent on few other factors. So you have the basin shape and stream order. Okay, over here you can see with lower number of stream orders, okay, the discharge is lower. Okay, but more, number of stream orders, the, the bank full discharge will get, it will cross, it will be crossed, and you can have chances of flooding. Over here, the shape of the basin, then steepness of profile. Okay, uh, then you have drainage density. Okay, higher the drainage density, more the chances of, flooding. Okay, and channel discharge you can calculate using the width of the channel, the depth of the channel, the velocity. Okay, so channel is nothing but the velocity of the water that is flowing into the cross sectional area of the, channel. So flood intensity is influenced by the rate of runoff, channel pattern and shape, number of tributaries, and the distance downstream. Okay, floods. Suppose, the slope is, kind of, steepness of the flow. If there is more steep slope present in that area, the chances of floods would be higher, because, there's sudden kind of input due to the, steeper slope over there. Okay, so these are some factors that are going to govern how intense the floods are going to be. So as we have learned that, floods are, you know it's a natural occurrence. Okay, right now we also have, urban, man-made causes for floods, but usually the floods are natural processes. Okay, but why do we need to mitigate the risks that are associated with flooding? Is because now the, kind of significance of life and property is more. Okay, we don't want loss of property, we don't want loss of life. So it's important for us to, find ways to mitigate the risks that are present or that happen due to flooding. Okay, so the first way of, flood management is to delineate the flood hazard zones. Okay, so you can have four flood hazard zones. The first one is where you have active floodplain areas. Okay, the areas where are associated with the deposition and creation of floodplains. Okay, mostly the mature stage of the river. Okay, then you have flood hazard zone 2, that is the alluvial fans and plains. Okay, so alluvial fans, if you remember in the last session, I explained that alluvial fans are, where the kind of the slope changes, okay, from a steeper slope. Oh, Kuldeep, so you're from flood hazard zone too. That's good to know. So you might already be, aware of the kind of flood related, hardships that you face over there. Okay, so alluvial fans are usually formed at the foothills, okay, where there is a sudden change in the slope, and the river kind of deposits all sizes of the sediments in a fan shape. Okay, so these are flood hazard zone 2. Then the foothills of Himalayas are kind of an example over there. Then you have flood hazard zone 3. So these are, where drainage channels are both erosional and depositional. Okay, and the gradients, are operative and along gradients of generally less than 5%. Then you have flood hazard zone 4. So this is where you have steep gradient drainage. Okay, so where the rate of incision is also is more over here. Okay, and you have relatively coarse bed load material also present. Okay, so these are some kind of qualitative distinction of the different flood hazard zones. Okay, in the map that I had shown over here, you can see that the flood prone areas are mostly in this area. Okay, so these this is the region where the large river systems of India are present. Okay, so you have Ganga, you have Yamuna, then you have Brahmaputra over here. Okay, so because this area is mostly largely supplied water by these big drainage systems. Okay, so these areas are much prone to uh, you know flood floodings over here. In the south, you can see that the areas are smaller in nature, but they're still present because of the um, presence of Krishna River, Godavari River, Kaveri River. Okay, then you have Narmada River in the western part. Okay, over here you have the Mahanadi River. Okay, so these river systems, which are much bigger in nature, they have larger drainage basins. So these areas are much prone to flooding. Okay, so now we know that India as a whole, like majority of the regions in India are flood prone. Okay, so it is important for us to understand how we can kind of decrease the effects or the bad effects of these floods. Okay, so you have hard methods. What are hard methods? That you can stabilize the river banks. Okay, using natural materials, or building structures which is going to hold the river bank in place. Okay, so the example over here in this diagram is the riprap. Okay, where large dumps of rocks are put in place along the river's edge to prevent the water from eroding the bank. Okay, the more erosion there is going to be, the larger the the area is going to be. Okay, and when there is more erosion, the floodplains or the valleys are going to collapse. Okay, and that is going to affect the flooding intensity over there. Okay, so to prevent erosion of the river banks, we put in such structures called ripraps. Okay, So you can see that before, the channel was, going like this, and this area was eroded and, sorry, this area got eroded and got deposited over here. Okay. So to decrease, to, prevent the erosion of this area now, okay, they built, they made provisions to have riprap over here. Okay. So now the water cannot erode this material. Okay, and if there is, increase in the kind of the water level over here, okay, it can be accommodated all the way till here. Okay, and this is not going to, involve in extension of the river bank anymore. So it is not going to affect the areas close to the rivers. Okay, so these are some of the ways where, how it was before, and then later on how it was, after the riprap, how it appears. Then you have some soft methods also. Soft methods are, is planting more trees, or, other vegetation along the river banks, okay? And more the tightly the root, or the more densely the root system is going to be, the more it can hold the soil over there, and it will prevent the erosion, okay? So that is soft methods. Obviously, riprap is expensive, it's costly methods. So soft methods would be a much preferable way, but obviously it takes a lot of time for, such deeper root systems to develop. Okay, so that is one of the drawbacks of soft methods. Also, we can create dams. Okay, we know that dams, serve both the purposes. It can control the flow of the water downstream, and it will also actually act as a reservoir for areas which have issues with, water, the availability of water resources. Okay, so this is a simple cross section of the dam to make you understand what is the upstream and what is the downstream. So this part is the upstream, that is like the reservoir, and this is the downstream. Okay. So when the water is released, you know that from here, from the spillway, the water is going to, flow downstream, and then it is going to flow along the river course. Okay. So, but there are some environmental impacts of these dams, okay? So, sometimes even failure, dam failures can also cause flooding. Also, if sometimes a large amount of water is released from the dam, okay, so the sudden increase in the quantity of water that is flowing downstream increases, and it will cause flooding in the neighboring riverbank area. Okay, so these are some of the issues with building dams. You we created dams to kind of restrict the flooding, and also help in, supplying water to remote areas, but there are also negative impacts. Okay, so some of the environmental impacts that, kind of take place due to the construction of dams. So in the upstream, you have, siltation, your amount of fish yield is, moderately it increases. Okay, and then downstream, okay, downstream there will be less sediment supply. Okay, there is no nutrient supply. The fish yield kind of decreases in the downstream region. Okay, so these are some of the negative impacts of the dams that are present, but it's a kind of, give or take relation with creating dams. There are good and bad to it, but we need to understand that the dams are, sometimes responsible for the flooding that happens, and it also obstructs the natural flow, or the natural course of the river. Okay, then there is another phenomena which kinds of, hinders the flow of the river through the, through during its life, during the river's lifetime. Sorry, the slide is not changing. Yeah, so that is debris flow. Okay, what is debris flow is, suppose the amount of bed load, okay, has increased. Okay, so or over here you can see that this is the river that is flowing, okay, and there is debris and it is flowing into a lake maybe. Okay, so there is debris over here. Okay, it will flow, it will obstruct the flow of the river. Then you could have a tributary. There are, these are different kinds of flow. First is the complete blockage. Okay, because of this debris flow there is complete blockage over here. Okay, there is no uh, it has formed a lake over here. Okay, over in the B part there's partial blockage. Okay, this is the upstream area, this is the downstream area. Debris is what? It's actually the deposition that is, how the debris flow happens is the depositions that is being formed in these banks of the rivers. Okay, suppose larger sizes of sediments are, kind of being deposited in the um, banks of the river. Okay, maybe due to say slope instability, there will be a sudden disturbance and entire material that is present on the banks of the river is going to flow down. Okay, so it can block the river course. Okay, so it will not allow the water to flow anymore down in the downstream direction. Okay, so it will block over there, or it will make the or it will kind of force the river to erode the bank which on the other side of the where the debris flow has happened. You can see over here that this river is flowing. Okay, so due to the debris flow there is a blockage in this region. Okay, so what it starts doing is it starts eroding this bank. Okay, this side river bank, and this will again induce a bank slope instability. Okay, because the erosion is happening, the stability is going to get it will change with time. Okay, so you could have complete blockage, you could have partial blockage, or you could have a submerged blockage because of the debris flow. Okay, over here you can see the cross-sectional view and also the plan view due to how debris flows can happen and affect the flow of the river. Okay, so I think this is kind of the end of the fluvial geomorphology. I think next week sir is going to take up the other agent which is forming geomorphic landforms. So if you have any questions till now with respect to what is taught today, you can ask now. For those, yes, Kuldeep?
Ma'am, actually, I was unable to submit two of my assignment this past week.
Okay.
So, is there any problem? Actually, I don't know. The first one, I was able to solve that, but the second one, I just could not. I was busy. So, is there any
Okay,
problem?
I think you can drop a query in the discussion forum regarding this, because actually I am not involved in the kind of these examination and assignment submission activities. So maybe you can drop up this issue in the discussion forum, and the respective TA will handle it, or the instructor might handle this. Okay.
Sure, ma'am.
Okay. Any other question regarding the content or the assignments or the solutions?
Actually, ma'am, it was my exams for past few days, so I was
Okay.
a bit busy, and now I will rewatch your videos on YouTube. Then
Okay.
I will
No issues,
ask
no
you.
issues. If you have any queries, then you can put in the discussion forum, mentioning that it is regarding the, live session YouTube videos, or you can, comment in the video itself, and I will try to cross check and try to, clear your doubt in that. For anybody who joined late, I will again put the, YouTube channel link and the Google Slides link for the content. Okay. Any other question by anybody regarding the today's? class or the lectures.
Excuse me, ma'am.
Yes.
Uh, as you have said that the superimposed जो ड्रेनेज पैटर्न है
Hmm.
वो हमारा डिस्काउंटेंट के जो ड्रेनेज पैटर्न उसके अंडर में आता है।
हाँ.
तो तो मैं ये पूछ रहा था कि सुपर इम्पोज ड्रेनेज पैटर्न में
Hmm.
जो अंडरलाइंग डॉक है उसके साथ उसका जो ड्रेनेज पैटर्न का संबंध रहेगा या नहीं रहेगा, मतलब रिलेशन रहेगा या नहीं रहेगा?
नहीं रहता है, वही है कि वो जो पहले जैसा था, ठीक है, पहले स्टेबल स्ट्राटा में जैसा था, ठीक है, वो वैसा फ्लो कर रहा था। सपोज वहाँ पे अपलिफ्ट भी हो गया और इरोजन भी हो गया, ठीक है, उसका कोई रिलेशन नहीं है उन दोनों एक्टिविटीज से। वो जैसा वो पहले स्टार्टिंग में फ्लो कर रहा था वो वैसे ही फ्लो करेगा, पर जैसे दो दो चीजें हो गई ना वहाँ पे, अपलिफ्ट भी हो गया और इरोजन भी हो गया, ठीक है, सो it is kind the drainage will appear not to be related to any of those.
थैंक यू मैम।
Okay. Any other question by anybody? Okay, so if nobody has any question, I will end the class here today. I will try to incorporate, geological examples of the different drainage patterns that Kuldeep mentioned. And I will update them in the Google Slides either by today, tonight, or at the most by tomorrow morning. It will be updated, and the links of these are also shared in your, NPTEL platform in the left hand side, in the left hand side column. Okay, as problem solving sessions. So you can check from there also, or you can follow my YouTube channel, and you will get kind of, the new, whenever it's updated or the recorded lecture, you can see over there. Okay, so thank you so much for joining today's live session. Hopefully it has helped you, and hopefully you will join in the upcoming live session again and discuss and interact with me. Any queries you can put in the discussion forum, or you can comment. Okay, so thank you so much.